Good day everyone, and thank you for joining me today as I present my research proposal titled Leveraging Data Mining Algorithms to Analyze Learner and Educator Behavior Patterns for Enhancing Student Success. My name is David Gabriselase, and I'm a graduate student at Athabasca University School of Computing and Information Systems under the supervision of Dr. Graf. Today I will outline the objectives and methodology and anticipated contributions of this research, as well as its potential to inform educational policies and practices. I look forward to sharing this research plan with you and welcome your feedback as we explore how data-driven strategies can shape the future of education. Allow me to take a moment to briefly talk about the research background. The rapid increase of digital learning platforms and student information systems has created quantity of data, offering outstanding opportunities to analyze and improve educational outcomes. However, many current approaches to educational data mining focuses narrowly on isolated aspects, such as learner behaviors or academic performance, often neglecting the critical interplay between learner and educators. This research seeks to address those gaps by employing advanced data mining algorithms to evaluate the behavioral patterns of both learners and educators, aiming to identify correlations, predict outcome, and recommend actionable interventions. The proposed research emphasizes an integrative approach exploring how interactions between learners and educators influence student success metrics, including engagement, retention, and academic performance. The objective of this research is to integrate and analyze behavioral data from learners and educators, such as participation trends and feedback frequency, to model their interactions. Also, to evaluate how temporal learner behaviors such as study hours or attendance trends influence academic performance. Last but not least, to create predictive and prescriptive models for student success using advanced data mining techniques like ensemble learning, sequence mining, and graph-based clustering to uncover complex patterns. Literature review. The literature review highlights significant advancements in educational data mining, but also reveals critical gaps. Studies have demonstrated the predictive power of data mining techniques, such as a study made by Algemir showcased the strong predictive power of data mining techniques for student performance. But the focus was largely on academic metrics, ignoring the behavioral dimension. Other study by Zamdin and colleagues highlighted the potential of automated machine learning, in short, AutoML, for predicting student success, focusing on academic performance. However, this approach neglects the role of educator behaviors in shaping outcomes. Other study demonstrated how digital logs could reveal patterns in learners' outcome. Yet, their implementation did not account for dynamic interaction between learners and educators. Also, other studies analyzed self-regulated learning behaviors using temporal patterns, but they overlooked the influence of educators on those learning behaviors. Also, other research shows that the teacher performance evaluation through decision-making frameworks. However, the study did not explore how those practices impact student success metrics. Overall, those findings illustrate the progress made in educational data mining, but also reveals ongoing gaps. For example, current studies focuses either on learners or educators, rarely exploring their combined influence on student success. Another gap is lack of holistic behavioral data. Most research neglects the interactions and dynamics between learners and educators' behavior. Also, other research shows the gap in techniques like assembly learning and process mining are underexplored in educational context. And study often prioritize grade while overlooking behavioral and contextual factors. Last but not least, few studies analyze how temporal patterns such as study habits align with educator feedback and intervention timing. Those gaps present opportunity to advance the field by integrating and expanding on the dimensions. To address those research gaps, I have formulated a research question to carry out my study, along with 3 main hypotheses to test. So, the core research question driving this research is, how can data mining algorithms be utilized to evaluate learner and educator behavior patterns and assess their impact on student success? This question focuses on uncovering the dynamic interplay between learner and educator behaviors, exploring how those interactions influence outcomes like engagement, retention, and academic performance. The goal is to develop a predictive model and actionable insight to enhance student success through data-driven approaches. This research is also guided by 3 key hypotheses. Hypothesis 1, data mining algorithms can effectively predict student success using integrated behavioral data from both learners and educators. 2, specific educators' behaviors such as feedback frequency and teaching methods have a measurable impact on learner success. Third, temporal patterns in learner behaviors like study hours and participation trends are significant predictors of academic performance. Those hypotheses aims to explore the interplay between behavioral and outcomes to generate actionable insights for improving education. Methodology. This study uses a mixed methods research design, which combines quantitative and qualitative analysis. The quantitative analysis part will focus on analyzing large-scale behavioral and academic data to uncover measurable patterns and trends. Techniques like classification, clustering, sequence mining will be employed. On the other side, qualitative analysis will add depth to the finding by interpreting contextual data gathering through the educator and learner feedback and surveys. The integration of those 2 approaches ensures a complete exploration of the interactions and relationship within the dataset, balancing statistical findings with narrative context. Data collection plan. To capture a holistic view, data will be collected from multiple sources. One source could be digital learning logs. Those logs will provide insight into attendance, participation, and submission patterns from learning management softwares or systems. Other source would be academic records. Data such as grades, assessments, feedback, course progress, and financial aid reports will help qualify academic outcomes. Third source could be from survey data. Learners and educators will share their perspective on engagement and interaction, providing qualitative insights to complement the quantitative data. Once the data is collected, the next step is to prepare the data, which involves 3 steps: cleaning, transformation, integration. In the cleaning step, missing data would be addressed, inconsistent data would be considered to be fixed as well. And also, standard formats would be applied across all data sets to ensure compatibility. In the transformation state, categorical data will be encoded to be compatible with 13 algorithms. Also, numerical data will be normalized for consistency during analysis. Third step is to integrate or merge data from different sources into a single cohesive data set. Those steps are very important for ensuring accuracy and reliability in the data analysis phase. With the prepared data, we can apply the following data analysis techniques. Algorithms such as decision trees, random forests, neural networks, and ensemble learning will be used to build predictive modeling and predict students' success based on integrated behavioral and academic data. Clustering technique will be used to group learners based on shared behavioral patterns to identify at-risk groups or high achievers. Also, sequential analysis technique will be used to analyze study habits and attendance over time to reveal trends or critical points of intervention. Also, we'll analyze how specific educator behaviors influence the learner's outcome, exploring actionable relationships through correlation and causation. Those techniques provide detailed insight and overarching patterns to address the research question. Ethical consideration. Ethics play a crucial role in this research. So, all datasets will be anonymized by removing personal identifiers, replacing them with aliases to protect participants' identities. Data will be stored securely in encrypted systems with access restricted to authorized personnel only. Participants will give informed consent, fully aware of how their data will be used in the study. Also, the algorithms and methodology will be carefully reviewed to ensure fairness and minimize potential bias in the analysis. To ensure compliance, this research will obtain Institutional Ethics Board approval before data collection begins. Timeline and milestones. The research will be implemented over 5 stages. The first stage is writing proposal and ethics approval. Second, data collection preparation, including cleaning, transformation, and integration. Third stage, data analysis, applying advanced techniques outlined earlier. Fourth stage is synthesize and reporting, consolidating results, and drafting recommendations. The final stage is writing thesis and defend it. Each phase builds logically on the last, ensuring a structured approach to address the research objectives. This research will make significant contribution in 2 areas. By integrating learner and educator behavioral data, it will advance the understanding of their combined impact on student success, filling critical gaps in educational data mining literature, and shared new knowledge with the research community. Also, this study will provide actionable insights for educators, policymakers, and institutions. Those findings will inform strategies to enhance engagement, retention, and performance, directly influencing how educational systems support student success. The research findings will be effectively shared to reach both academic and practitioner audiences, ensuring the work has a broader impact on the field of educational data mining and beyond. So this research targets to publish in IEEE Transactions on Learning Technologies, Journal of Education Data Mining, ACM Learning at Scale Conference, and also Artificial Intelligence in Education Conference. As we come to the end of this presentation, I want to briefly summarize the key points we have covered. This research aims to leverage advanced data mining algorithms to analyze the behavioral patterns of both learners and educators with the goal of enhancing student success. By employing a mixed method approach, combining both quantitative data analysis and qualitative insight. This study will uncover valuable patterns that can lead to targeted interventions to improve student engagement, retention, and performance. We have identified critical gap in the current research, including the lack of integrated analysis of both learner and educator behaviors and the limited application of advanced algorithms. This research intended to fill those gaps, providing a holistic understanding of the factors that influence student success. Furthermore, this research has a potential to make significant contribution to the field of educational data mining and provide actionable recommendations for improving educational outcomes. Ultimately, the research finding will be published through high-impact academic journals and conferences to ensure accessibility and engagement with a broader audience, from researchers to educators and policymakers. Thank you for your time and attention. I look forward to any questions, feedback, or suggestions you might have. Please post your comments in the course general discussion. Thank you. Have a good day.